Hello, today I'm going to talk about manufacturing process input variations, how it impacts quality, how data analytics in 4.0 can be applied to recognize the manufacturing process variations so that immediate action can be taken to manage those process variations towards a consistently good quality products. I'm sure your customers does not want product with unstable quality.
Hello everyone, I'm Evelyn Tan, an influencer in quality engineering, to bring you another lessons on how to apply quality engineering tools and concepts to be proactive in achieving consistently good quality products. So let's get started.
Let's get to know our friend, the manufacturing process, better. Every items that you see around you, from the chair you're sitting to most food that you are eating, comes from a manufacturing process. Manufacturing process is a transformation of a raw material to the end goods for the consumer market. In the modern day, raw materials sourced from Mother Earth will go through a series of manufacturing process in different entities before it reach the customers. All manufacturing process inputs will have materials as a key process inputs. Man that needs to work on the manufacturing process to transform the material. The machine that helps to transform the material, the method that is used to transform, and also the measurement process that measures the products or the material as well, and the environment is also another process input which is important for those products that are sensitive to environmental changes, such as those sensitive electronics components. The material will go through a transformation process, and then it will be converted into a process output or a finished product of that process. And this process output could in turn become a manufacturing process input for another process until it becomes an end product which can be used by the consumer. Each of the process input that we see here, the man-machine methods material measure, will have some kind of a variations. For example, for man, it could be a different operators or even the same operators, but they could be operating slightly different from time to time. It's either between variations or within the man itself, there is also a variation. And in machine, there could be a variation within the machine itself. The condition of the machine could be different. The natural wear and tear could cause the machine to have some kind of variations as well, or a different machine that is used. Next is the method, where it could have different SOP at different time. There could be changes, subtle changes, and the material itself, very obvious, it will be lot to lot differences. The measurement process, there could also be differences in terms of the person that measure or the condition of the equipment, and next the environment will have changes all the time. So these are all the source of variations that will cause the process outputs itself to also have a variation in this case. There are two types of process input variation which impact the process output, the end product, in a different way. Here, we shall look at the first type of variations, which is known as common cause variations or natural variations itself. This type of common cause variations are actually inherent to the process, and also it is a very small variations such as material. There will be a small acceptable variations from batch to batch. Machine, there could be a natural drift of shift from time to time, which is acceptable. And the man that operates within the variations by following the methods, there could be a subtle differences. And also the measurement process, there is also an acceptable range of variations. So this type of variations will result in common cause variations for the product itself, where it is actually quite stable and also predictable over time, and it should be more or less within the range or the control range itself. If the process is set up properly, the key parameters of the process output will also be within specifications. The second type of variation is known as special cause variations or assignable cause variations. These happen when something unexpected change in one or two of the process inputs itself. It could be that suddenly there is an untrained operators, and the machine, it could have used a different type of unqualified machines for the product itself. And the methods, there could be changes in the SOP, or there are no work instruction that has been approved before it is used in the manufacturing line. The material itself, there could be new batch of material, or the suppliers is giving materials that comes with a special cost variations, or there could be also using new vendor that is not qualified, and the measurement process, the environment which is out of control. All these variations are actually unpredictable, and they are not stable over time. Therefore, you will also produce an output with special cost variations, that there could be spikes or changes that is not predictable. If this happen, most of these type of variations actually happens to one or maybe two process input. If it happens all the time to all process inputs, this means there's something wrong, and this type of process should be disqualified. Even if it happens to only maybe one process input, it could have dire consequences to the product itself. And I plot if I plot a chart over time to check the critical parameters, I can see a certain spike. And these spikes, needs to be removed at once, and this means that the special cost variations should be eliminated in order for the process to go back to normal or to have just common cost variation. Since we already know there are two types of variations and our aim is to get consistently good quality product with as little variations as possible, therefore we need to learn how to manage these two types of process variations well. We cannot eliminate common cost variations, and we can only control the variations to the smallest possible from these variations to this variation here using a Six Sigma approach, especially if you are in a high volume type of environment. We can reduce the process input variations and achieve Six Sigma quality from here. So in terms of common cause is that we need to know that it exists all the time, is happening to all process inputs, and it does not have any big consequences to the product quality or noticeable consequences to the product quality. That means it's still within acceptable range, and also the only way to manage it is to actually reduce the variations through a Six Sigma approach. You can refer to my another video on Six Sigma quality given at the link below or at the end of this video. The next variation is a special cost variations which happen only at one time, and it could be due to a single source and must be eliminated immediately, and it will have big problem to the output if it's present. So normally we would like to eliminate, or we want to eliminate common cost variations, and one of the ways is through corrective action methods such as 8D approach, which will remove the spikes from the process and it will go back to the common cost type of variations in the process input level. There have been a lot of confusion to distinguish these two types of special cause and common cause failure, or process input which cause failure. Treating common cause process variation as special cause will drain the resources, as it is not possible to eliminate common cause variations under normal circumstances. A good example would be surface particle, which have very low reject rate on a product, and as we know, particle exists everywhere, which is a common cause variations. And we have to take extreme measure if we want to eliminate particle, such as produce the part in vacuum or in space, outer space, where there's no particle. And this is really not an economical, viable solution. On the other hand, ignoring special cause variations will lead to disasters to your customers, as this type of failure will be noticeable immediately by your customers. Do leave me a comment on your experience in dealing with process variations and process variations that you could have difficulties in differentiate. There are times like this, and I could also share some insights based on my experience if you leave me a comment. After we have understand who our real enemy are in the manufacturing process, next is that how do we recognize the common cause and special cause variations? The method used to identify process variations has been quite manual even till today, of using charts or SPC charts to identify if there's a presence of special cause. We are already in the era of IR4.0. Therefore, it is time for companies to work with experts in this field to ensure that the data infrastructure set up are able to identify all the critical parameters in the process input for data collection and ensure that data collected are accurate and also able to target the process variations either to reduce or to eliminate. So it is really very important that this type of automation should be able to help in predicting that if there is a potential special cause that's present and trigger for attention, rather than producing thousands of parts. Worse still, if those parts has already reached the customers. Please refer to my another video on the foundation of data collection. I would also appreciate if you could share that your manufacturing is using IR 4.0 to help identify process variations in the comment section.
Do give me a thumbs up if you like and have benefited from today's video, which is especially prepared for you to hack into the key areas to achieve good results. Please do subscribe to this channel to get notified on the future video, and appreciate if you can leave a comment on what you would like to learn. I would also appreciate if you can share this channel with all your friends. Thank you and see you in my next lesson. Bye.